Hey guys, let's look at the Pythagoras theorem. The aim of the Pythagoras theorem is to find a missing side length in a right angle triangle. So a right angle triangle has three sides and one of the angles is always 90 degrees, and we label that with a little square. Now the side opposite the 90 degrees is called the hypotenuse, and we always label it C. The hypotenuse is the longest side in a right angle triangle, and the other two smaller sides are labeled A and B. Now, which sides you label A and B are interchangeable, so here's another way how we can draw that. As long as the side opposite the 90 degrees is always labeled C, the Pythagoras theorem will be applied correctly. Now let's look at some examples. Let's label this first. So we know that the hypotenuse is the longest side of the triangle, and it's opposite this 90 degrees. So that's our C, the hypotenuse, and the other two sides can be labeled A and B. So I'm just going to label them like this. All right. So this labeling is important because once you identify what A, B, and C is, then you can go ahead and use the Pythagoras theorem, which is A squared plus B squared equals C squared. So for example, if I said that this side here is 3 and this side here is 4, find C, then all you would do is replace this A and B with the lengths that they are, 3 and 4. So to find C here, we can replace A, B, and C with the values that they are. So we know that A is 3, B is 4, and C is, well, we've just labeled it C. We want to know what it is. So let's sub that into the Pythagoras theorem. So that's 3 squared plus 4 squared equals C squared. Now 3 squared really means 3 times 3. So that's going to be 9. Plus 4 squared is 4 times 4, which is 16, equals C squared. 9 plus 16 is 25, equals C squared. So now to get C, we need to square root both sides, and C is going to be 5. So this square root sign can be found on your calculator. So if you want to do square root of 25, you press that button first, and then you type 25. And it will tell you that that's 5. And what this means is that 5 squared equals 25, because 5 times 5 is 25. So for this question here, you can get away without using a calculator, because you know that if C squared is 25, C has to be 5, because 5 times 5 is 25. All right, so as we just looked at, the Pythagoras theorem is that A squared plus B squared equals C squared, where A and B are the smaller sides of a right angle triangle, and C is the hypotenuse, which is opposite the 90 degrees and the longest side in a right angle triangle. So let's look at an example. Find the hypotenuse X in the following question. So again, the first thing you want to do is label your A, B, and C's. So in this question, we know that A is 5, B is 12, and C is X, which is what we're trying to find. Now let's put this information into the Pythagoras theorem formula. So which is A squared plus B squared equals C squared. So that's going to be 5 squared plus 12 squared equals X squared. Now on your calculator as well, you'll see a little button that says a little square sign, and you can press that to do 5 squared, which is really 5 times 5. So 5 squared, that's 25, plus 12 squared, so that's 12 times 12, which is 144 equals X squared. 25 plus 144 is 169 equals X squared. And now to get X, we need to square root on both sides. So X will be square root of 169, and that is X equals 13. So we know that the hypotenuse X is 13. So this is 13 units long. if this length is 5 and this length is 12. All right. Now we can also use this formula to find a shorter side. So let's look at an example. So find the shorter side x in the following question. So again, let's label our sides. And subbing this information into our Pythagoras theorem, a is 9 squared plus b is x squared equals c is 15 squared. And now we just want to solve for x. So 9 squared is going to be 81 plus x squared equals 15 squared, which is 225. Now we've got 81, positive 81. Remember, if there's no sign in front of the number, it means it's a positive number. So let's get rid of this 81 by minusing 81 from both sides. And then this will cancel, so we'll have x squared equals 225 minus 81, which is, let's work that out. You can do this on the calculator as well, which is 144. And now to get x, we need to square root on both sides. So when we do square root, the square and the square root cancel, and square root of 144 is 12. So we know that this x value here is 12. Now, sometimes you'll be asked to leave the answer in the exact form. So what you would have noticed in the previous examples is they were all perfect squares. And what I mean by that is when we took the square root, the answer was always a whole number. But sometimes the answer is not going to be a whole number. For example, here. So in this one, we want to find x. So let's follow the steps that we have been following so far. Let's label it first. So a is 4, b is 7, and c is x. And putting this information into a Pythagoras theorem, we have 4 squared plus 7 squared equals x squared. 4 squared is 16 plus 7 squared is 49 equals x squared. Now 16 plus 49 is 65 equals x squared. So x is going to be square root of, so if you take square root on both sides, we're going to have x equals square root of 65. Now this is considered leaving the answer in an exact form. And the reason we would leave it like that is if we did take the square root, we would get a decimal answer. Now, sometimes we'll be asked to leave the answer in the decimal form. And so let's look at an example of that. So find x and round the answer to 2 decimal places. Now I've gone ahead and labeled what each side is. So our a is x, b is 8, and c is 15. So let's put this information into our Pythagoras theorem. So we're going to have x squared plus 8 squared equals 15 squared. So remember, c is always the side opposite the right angle. Now that's going to be x squared plus 64 equals 15 squared, which is 225. Now let's get rid of the plus 64 by minusing 64 on both sides. That's going to cancel. We're going to have x squared equals 161. So x is going to be square root of 161. If I put that in the calculator, remember it's the button that looks like that. So we're going to press that first and then type in 161. And that gives us 12.68. Now 688, and we want to round off to 2 decimal places. So we look at the 1 to 3rd number after the decimal point, and because this is 5, this is greater than, it's 5 or above, it's 8. So we're going to round this 8 up to 9 because of that. So to round it off, we can get rid of that, and this 8 becomes a 9. So that's the answer. So when it's asked to be rounded off and to a decimal place, we would write it like this. And if it was asked to be answered in exact form, we would have just left it like that, as we did in the previous example. All right, so that's really the summary of a Pythagoras theorem and how to use it to solve questions where you have to find the different lengths of a right angle triangle.